Papa and praises. The only thing within my mind in the money. This is the only way. I woke up like this. Now I'm getting text now. The only thing where I see.
Probably you have bug fixes or some production issues. So that should not be a challenge. The idea is that application should be readily available for that end user. So you have an error that is occurring on production. So that error should not hinder another user that is trying to use that platform. So how that platform is readily available to that user. What are the factors that need to make the application available? That's what we're going to be talking about today. So let's take a step forward and say, ask the question, why will organization care about modernizing application delivery process? So this is actually not a valid question. So if you say an application is working today, then 5 years later, if you decide that the infrastructure and the technologies used to power this application today, 5 years later, that infrastructure is outdated. So if you as an organization decide that you don't want to follow the trend in technology, it's just a recipe for disaster. So the major challenge now is that the organizations that decide that, okay, they want to modernize their application, they have the reason why they decide to. So let's take, for instance, now you don't want to modernize your application, that's like the end of your business. So we have an application today, and the basic idea now is that the processes we're having today in applications that we're delivering now, we're seeing where we're having change in requirements. So today you have there's a project now that you want to work on, like an organization. You got a requirement from your customers. So the idea now is that you need to work on that product and get that product to production. So there are factors affecting the delivery of those products. So now let's take, for instance, now speed, resilience, scale, and reduction in cost. So we're talking about modernizing the application and how this thing affects them. So there are three main traits of modernizing applications. So this is elasticity, availability, and agility. So let's take, for instance, elasticity. What do we mean by elasticity? So the concept is your application delivery process should be able to scale up and down on customer demand. So we're having, so elasticity, we're saying ability to go and shrink on customer demand. Now, the process we have today in delivering applications are you have your applications deployed to an environment. So the models organizations are using today that, okay, to cater for high demand. So let me say later in the future, you deploy your application in an environment with high resource. So let me say your application needs like 4 GB of RAM to run. Today, because you are not sure of the uncertainty that might occur, you decide to deploy the application on a 16 gig infrastructure. Now you've scaled that application, but you did it wrongly. One, you've highly increased the cost of scaling the application. Meanwhile, your application is just sitting down there doing nothing. So elasticity is the ability. So when we say we're modernizing an application, we're saying elasticity is the ability for that application to be able to, the delivery process should be able to scale up and down. So when the customer demand increases, the delivery process should be able to make that your application available. Then when the customer demand reduces, that application delivery process should be able to go back to the form. But this is thereby saving you cost. So we'll move over to the next one, availability. Availability. So the idea here is that applications should be readily available to the end users. So let's take, for instance, now today, we all use WhatsApp, Twitter, and Facebook, and the rest. Those applications are 100%, let me not use 100%, 99.999% available. Now the question we should be asking ourselves, how are these organizations doing this? We're seeing companies coming up today, majorly in Africa and everywhere, then we're trying to, the idea is to probably build products that will be readily available and provide services to our users. Now we're seeing companies facing challenges of keeping that application up. So today now, if you pick up your phone and you send someone a message on WhatsApp, if that message doesn't deliver, the next thing you blame is MTN or your mobile network, that the network is down. Even if WhatsApp is down, you yourself, you can't believe that WhatsApp is down due to the availability of WhatsApp 100% of the time. But in the case of, let's bring it home now, you pick up, so let's not start naming applications. You pick up your application and maybe you try to do a transfer or so. So once you do that transfer and it goes, the next say, thank God, the thing went. So we're actually shocked that our services are up. So when you see we're having cases where maybe you want to make bill payments and you'll be like, man, I don't know if this stuff will work now, if I should try it. Then if it happens, that you're shocked. The reverse should be the case. You should be shocked when the application is down, not when your application is up. So availability now, how we make that application readily available to the customer whenever they need it. Now the next is agility. The ability to iterate on requirements and customer experiences quickly. So today we're having cases where organizations are moving over to product-based delivery. So everything now is as a service. We have software as a service, infrastructure as a service. So no one is building project anymore. So the idea is to constantly build revenue. So those your products you're building today are constantly evolving. So the idea is, how can you get feedback from your customer and put it back into your product and deliver that thing as fast as possible? So now you have a product now that you have, and the customer, you probably have some monitoring and stuff, and the customer complains that they need this feature or something went wrong. Now, what is the process involved in getting that feature or a bug fixed and delivered to the customer? That is the agility we're talking about, that speed. Then how to recover from disaster. So today we're having cases where we're having series of downtimes. We probably push an update to production. It's working fine on development, on dev. It's working fine on staging. Then you push the application on production. Then before you know it, everywhere is down. Then you have to go back the application. Now the process of rolling down our application now has led to a downtime. Now the process of modernizing your application is the ability, even if there is a downtime, even if there is a failed deployment, the application should be able to recover from that. So let's move on to say, how can we achieve this agility? So we've talked about elasticity, we've talked about agility, and we've talked about availability. So what are the processes involved in achieving this? So we should know that teams, this is not just like a one department stuff in an organization or a one-man project. So this is something that the teams involved in delivering the service needs to come together and decide that they want to take out the bottlenecks that are hindering the continuous delivery of good services to our end users customers. So that's giving the developers the rights to the developer needs. Then hopefully the developer will write good codes that can give the operation guys sleepless nights. So all those processes involved is what we're trying to see, how to achieve that. So there are factors that affect this stuff. That's what we're moving on to next. So what are the main factors that affect how our applications are delivered today? So there are two main factors that affect it. One is the application architecture, and two is the application delivery model. So when we say the application architecture, now we're talking about the platform in which the application is built on. Then we're talking about application delivery model is the process involved in getting the application ready. So we'll move first to look at the application architecture. So over the years, we've seen evolution in the application development process. So we've moved from monolithic application architecture all the way to service-oriented architecture, then now to microservice. How has these changes that has been implemented over the years affect delivery of this our application? So if we talk about monolithic, so the idea about monolithic application is you get this big bang application where, let me say, you start off with few requirements you got from your clients that the organization wants to implement. Then as new features and new requirement comes up, they keep adding to the code base. Now over the years now, you see we have one gigantic application that is just like a black box that nobody can manage. Even the whole developers you have in your team, everybody is scared to go to that code base. Now the idea now is instead of, so the idea now was not there that, okay, we can actually split up this stuff and make it easier for developers. So the idea was that we have an application, we have any feature we have, let's just dump it in that code base. So now that was okay as a then. Now the challenge with that was that making changes to that code base became a problem. So let me say you have a legacy application now that you have been running for like 5 years now. Then for sure developers come and go, organization structure changes. Then after some years now you have requirements from a client or so that they need to add a feature or so. So this application has been sitting there for 5 years. Developers coming and going, adding to that code base. Now when you get a developer that, can you add 1 or 2 features? Now, when the developer managed to add a feature, you see you're adding 1 feature and you're breaking 10 other features. Now the application begins to crash in different places. Now that is going to affect your availability, the availability of the application. So we're saying that this application goes to production, you're able to implement 1 feature, 10 other features are breaking. Now they will be back and forth. You have to start going back and forth, going back to development, take the application offline. In some cases you have to go back. So the monolithic application now was terrible for developers. But when it comes to the operation teams that are tasked with keeping the application running on production, that was like, how did I put it in my slide? That was operations heaven. Now we just have to worry about 1 application in production. Just 1 single application. If there's an update, we just carry that update and apply it to that production. We're not worried about whether any other stuff is breaking or not. Development aspects, it takes a longer period to get a feature on that application because the developer that is coming on board needs to study that, and they need to be proper testing back and forth to make sure that that code doesn't break anything. Where we move over as years progress, we move to the service-oriented architecture. So they saw that this monolithic application architecture was making development process slow. So to get a feature on an application was taking months, weeks. So the idea was, can we split up this application? So instead of having one single black box, let's break up the features that make up this app and split it into a different service. So service-oriented architecture is, so you have like your core app, then you have different services supported. So you probably have an application that you use to make payments, then you probably have a payments controller, you probably have a transaction controller. So the idea was to split it. Now that was good to an extent for the developers, but to the operations that was an extra headache. Because before I was maintaining just 1 application, now you're telling me to maintain multiple applications. So if I'm applying updates, I have to apply updates to multiple applications. While it's good for developers, like I said, operations, it was terrible. Then we moved over to microservices, which is what is trending today. Microservices now took the service-oriented architecture and say, okay, instead of we're splitting this application now into features, can we split it to the smallest part? So we say we have a payment controller. In that payment controller, we identify some of the parts, then further split that. Now the idea now is to make development process very easy. So you have a feature or you have a bug on a particular part, you just get a developer to work on that little part. The development process is very easy. The developer don't need to understand the full code base of that big gigantic app. But the challenge now was with the operations part of it. Now the operations now had to worry about multiple applications. Now this microservice architecture now is you're having 1 application, now you're having more than 10, 20 applications to manage that are doing that same thing. So to the operation side now, it was a big challenge. It was fine. Until we noticed we were still having issues. Now we have speed, but the applications are still not being delivered as they are supposed to. Now what was the challenge? Now the problem with waterfall model was you are in a particular stage, a requirement gathering stage. So the business managers or the product owners, so that is their particular stage where they get the requirement. Now what happens is that every stage there is an isolation. So what the business manager or the product owner is doing, the operations guy that is going to be maintaining the application, majority of the time is not aware. So there is an isolation in information. So communication was a challenge. So in order to communication was the carrying. Then the other challenge was collaboration. So we're seeing cases where the process was like a hands-off. Once the business or product owner gets all the requirements it needs, it's just like a piece of, it's left for the development team to implement. So what you'll be hearing, are we live? Have you deployed it? So the business owner is not, or the product delivery officer is not aware of what the developer is doing. Our own or his own is just to get the feature, go and do this. Now the developer goes into his own silo. Takes 2 weeks, takes 2 months, I'm still on it, I'm on it, it's working on my box and all. Deploying and carrying dependencies that might not work in the current infrastructure the organization has. Now the operations guy is not aware of what the developer is trying to implement. Now the developer go and implement and just come and give us a load of application and be like, this is what is required for this application to work. So the idea was collaboration was not there. That was impeding the way application was being delivered. Then the other thing was the speed also was affected. So we needed to get an automated process. So we noticed that you have a working update. Then how you get the working update from the developer to the proper environment, each development, dev environment, staging of production was a challenge. So we needed to automate that process. Then last was monitoring and continuous feedback. Agile and waterfall model did not cater for that. So Agile and waterfall model just deploy the application, then there's a feature or a new requirement from the application for the. So containers, the idea with containers is to package that code and distribute it. So this changed everything we know about delivering applications. So today now, the way we treat our codes, you're a developer, you're working on a project. So probably you have a feature of bug you fix. You code what you guys do, then you push those changes to a central repository. So the idea now is when you code, build this thing and push the code and the environment to a central repository. So this changes, so now you're not just checking in your code now, you're checking in now it gives more sense to the application. Now you're checking in your application. So anybody can just get that your application and just run it on any infrastructure. So today, most of us would have cases where we probably want to work on the project and we require to install some dependencies, let me say MySQL server or Microsoft SQL server. So the idea is you go to Microsoft sites, then you go and download the binary, then you come and run the installation. Now you are seeing cases where I might carry the same box, I'll run Microsoft SQL server here, and I'll run it on the other box, it doesn't run. Then I'll start troubleshooting what's wrong. Probably I have a Windows update I've not updated. So this idea is everybody now is no more pushing a code or a binary. Everybody is pushing the whole environment. So today, if we move forward, and before moving forward, let's just take a brief look at what the benefits that container brought to the game. So the number one benefit is the portability. So the idea now is that your code is not dependent on the environment. So you can carry your application now and run it whether on Linux machine, whether it's a .NET Core, whether it's a PHP application. So you just run it on an infrastructure that doesn't even have PHP or anything installed, and it works. Because that application is moving with everything required for it to run. Now it brought about increase of deployments and developments. Then it also brought about consistent environment. So the possibility of your application running on your local machine and it not running on another box is impossible. That was what container brought to the game. And also related security issues. So we'll look at how this really help us, these security related issues. So we can't talk about containers without talking about Docker actually. So these are the people that brought about this game-changing sort of containers. So containers has been existing on Linux environments. It came with the kernel, but the idea was it was not fully utilized. So Docker came, explored that, and they developed a runtime. So what we had before was you probably want to manage costs. You have an organization gets a server to run the application on it. You want to manage costs and stuff. So you get the application and you get an hypervisor. So we are seeing cases of VMwares or VirtualBox. So what that does is that on your infrastructure, you probably got a 60 gig RAM or a very high spec. Then you run that hypervisor on that infrastructure. So what it does now is to create layers on that infrastructure and say, create virtual machines. Let me use that word, virtual machines. Now for you to maximize that hardware you bought to run your application. So the idea with containers is we are no longer talking about hypervisors now. We're talking about container runtimes. So instead of installing an hypervisor, you install a container runtime. Now what that does is it puts a layer on top of the infrastructure and you run your app directly on that. It's just like installing applications on your machine. Let me say on your Windows machine today. But those applications you are installing now, think they are running on their own operating system. So today what we have now is for you to maximize your hardware, you get an hypervisor and you split that hypervisor into different virtual machines. Now container runtime came in and said, you don't need to split that into different machines. Just install a container runtime and I will virtualize those applications. So when those applications are running, they will be running as if they are in their own environment, on their own environment rather. So let's get a graphical representation of how that works. So we see the containerized applications and the existing, what we are used to today. That's the hypervisor and the virtual machines. So what we need to do is get a container runtime on our infrastructure and run all our applications, those apps that has been bundled with their environment, and everything moves fine. So how does this work? So the idea with containers is, let's personalize it to Docker, is you get a Docker file, then you build your Docker image, then that Docker image is what is being run as a container. So you put your, so what it does is you get the way you pull code today. Let me say you have a dependency, you pull probably a for net library to use in your code. So the idea now is you want to run, you are building an application on PHP, with PHP rather. So instead of installing PHP on your local machine, what you just need to do is pull a PHP image. Then in the PHP, you create your own Docker file and say from this PHP image, get this PHP image and copy my code into it, then build an image. That image becomes immutable, it doesn't change. So someone cannot just come and alter that image. That image becomes fixed. So anywhere you run that image only runs that exact change you made. So if you pull a, let me say a MySQL image now. So today we've seen what is currently happening is that everybody, every big player in the industry now are shifting to the way, are adopting this container technology. So the way we deploy MySQL, the way we deploy SQL SQL Server, so they are all changing. So the idea is now we are pulling an image instead of running the installation on our local machine. So let's just take a quick look at how this really works. So so let me put this up here. So just to show us how this whole containers, a quick run shell and how this stuff works before we move on. So we want to, today now, if you want to set up a WordPress website, you need to pull the WordPress binary, run the installation, or whatever means you want. Now that WordPress binary requires MySQL, so you need to have a MySQL server installed on your local machine to do this. Now Docker came and said, we're changing the way everything works, so container, sorry. Instead of WordPress now to release that binary for you to install, WordPress will release the application to you, the full container, the full image. So what you just need to do now is to just pull that image, the way you pull changes from your Git repository into consideration availability. Once anything happens to that host, you are offline. So the advantage Docker or containers brought into the game is you can spin up multiple instances. You can just spin up 10 instances of your application, just like that, and have them running. But the challenge is how would you manage those containers? How would you get your IP, and how would you serve those containers? That was where orchestration came about. Now the orchestration is like, it is going to manage the life cycle of your containers for you and provide you additional functionalities. So who are the big players in this orchestration space? So Docker is the, let me say, the pioneers of containers. Definitely they will have the solutions to make them to properly maintain these containers. So we have to do what we call Docker Swarm. So the Docker Swarm now efficiently manages those containers for you. So you have cases where a container stops. The Docker Swarm will automatically start that container for you. You can automatically schedule disk space and whatnot. But that is just Docker. So that brought about the birth of Kubernetes. Now Kubernetes now came to the space and is doing what Docker Swarm is doing more efficiently with more features. Because Google have experience in this, on how they manage this orchestration. So what is Kubernetes bringing to the table? So Kubernetes is bringing, so my screen is so small, I don't want my screen is so small. Kubernetes is bringing storage orchestration. So we have a way of automatically managing those storage used by our containers. If you want to do that manually, it's not achievable. So let me say your organization is switching to a container space. Now you have all your applications running on a container runtime. How do you manage those storages used? So Kubernetes came with storage orchestration. It also came with service discovery and load balancing. So the idea is once you start a container, it automatically registers. You basically don't have to do anything. The only challenge is just to get your Kubernetes cluster up and running. So the major challenge with Kubernetes is just the expertise in managing it. But if you get your configuration right, it's just a win-win situation. Now we got a balance between development and operations. Now development can use whatever technology they want to use. Now the operation guy does not need to care. Whether you want to use Postgres or MongoDB or Daemon, is it Daemon or Node.js, I don't care. Get it and send me the application. I put it on my Kubernetes cluster. It manages the application lifecycle from service delivery to, this thing is so small, my God. From service delivery to horizontal scaling to automatic rollback. So you deploy an application to production. What you start hearing is probably I cannot log in. I cannot, what did you people apply? Can you roll back, please? Now you try to roll back. No, Kubernetes does that out of the box for you. You want to deploy a new chain to Kubernetes. It deploys that changes. First check if the application is working as expected before killing the other containers that are running, that are currently serving your customers. The possibility, the feature Kubernetes brings to us is like science fiction. Today, what you just need to do is just to specify a configuration and say, I want to have 10 instances of this application running. Connect it to this external IP. Make sure there is readily available. Probably when the CPU utilization goes to 50%, spin up a new instance of that container. When the utility reduces from 50%, automatically shrink the size of those containers running. So now you are having high availability because your application is almost impossible for your applications to go down. Because you are having multiple instances of that application, and those applications are constantly being monitored. Now we're having elasticity. Now you can shrink and grow the size of your application running on production with respect to the demand of your customer. Let me say you are shipping out your product today, you have just 10 users. Next month you have 50 million users. You don't need to worry about yourself. Your own is just get this onto your Kubernetes cluster. Make sure you have definitely, so where, I'll get to that, let's just move on. So it also provides horizontal scaling. So we're seeing cases where we have applications running today. Let me say your organization have an application running, so they want to make that application highly available. So what they do now is to vertically scale the application. So they add more RAMs to the server. So the application is currently using 90% memory. Issues. Let's go and get more RAM. So we knock it 24 gig RAM. Whether your application is using all those gigabytes of space, we don't know. Now that is cost wasted. Now we have the horizontal scaling, we have the secret and configuration management. So the idea is, now we're saying that we're giving developers the flexibility of having production experience. Now we need to cater for configurations and secrets. Definitely you don't want the configuration file, that the Docker file that the developer is using to build his image. You definitely don't want to have the live database in that configuration. So we'll see how this works. So the idea now is to properly manage the secrets and configuration needed for each Docker image. Kubernetes does this for you out of the box. So is there any other thing? Batch execution. So we're having cases where, now, you imagine how these big organizations do this today. You are seeing Facebook, they are serving application worldwide. Now they are releasing updates. Now you see cases where there's a feature release, this feature is only available in this region. We're having a downtime, this is only happening in this region. Now that flexibility comes with how you maintain, how you deliver your application. Today, with the traditional way we have in delivering our application, we cannot achieve that. So how can you say you want to make this feature available to just this particular person? Now, you need to go and get your network configuration skills and say, if this network traffic is coming from so person, or more, route it to this place. This server doesn't have this feature yet. Now, the idea of achieving that high-scale flexibility is not there. Now, Kubernetes and container provides that out of the box for us. So before we bring this session to an end, we'll probably just see a little demo of how our traditional application delivery process work today. So how we deploy this application, we'll probably get the code from the developer or whatever, we'll pass it to our CI/CD system, then we'll deploy it to our server. Then we'll see how that works and see how this modern way of delivering application, which is deploying application to containers and our Kubernetes cluster. So can we just do that? It shouldn't take a minute. So in order to achieve this, we are using a very sophisticated application with the latest and greatest technology. Talk about IoT, talk about what technologies we have today. This application, I will make the source code available to our developers. So the idea now is to see how we make changes today to code, see how it goes through a continuous integration and delivery pipeline, and see how we deploy it manually to our servers. Then we'll go ahead and see the limitations to that. Then we'll probably want to deploy that to a Kubernetes cluster and see the advantage we have today. So this application currently is running on, wow, you can see that. Just a minute. It's called the artifact. So the output of this project now is the built binary. So if you see, it is placed in a container. Now this contains the whole application. Now this is the contents of the application when you build it. So the idea now is, once we build this application successfully, we carry out test cases. Probably there are no unit tests, it's just a demo. Then it automatically pushes that code to the release pipeline to trigger a deployment. So what we're seeing here now is this deployment running. So whenever a new artifact is ready, the release phase now takes that, and depending on the configuration you have, it deploys that application to that environment as quickly as possible. So now we're seeing the deployment, so we just have one environment, the deployment to dev, where the application is running. So deployment successful. So the idea now is we've changed the header. So if we come here now, and we try to reload to see, now the application is caching. Now the same code that was run on the developer's machine, that built fine, we deploy that same code without an error to production, and now we are having a production error. Now this is where people start running up and down. Now go back, what do you do IIS reset and stuff. Now, but the problem is that it's still not working. So now this is part of the limitations we have. So you are pushing code, you're having back and forth, now your application is down. Now this is greatly reducing your application delivery to your end user customer. So the fix to this now is the container we're talking about. So if you check the repository under the pipeline, we have two pipelines that are there. So the idea now to just showcase this in this demo. Now we have two pipelines, traditional app and modern app. So in order for this traditional app to trigger, you need to make a change to the master branch. Now in order for this modern app to trigger, the configuration, let me, why am I not opening this? Just a minute. So in order for this to trigger, you just need to make changes to this README file. The reason why I made this, why I set this up is to prove that there was no changes made to the application, but it triggered the build. That same code was being deployed and it worked. So if we go now to probably the repository and say we enter the README file, and we'll probably make a change just for the sake of this demo and commit this change. So we made a change. Now what this does now is it triggers a build process on the modern app pipeline. Now you should be aware that we made change to both the master branch and so the commits. So we should be aware that we made changes to why is it not triggering? I made a commit just now. Did I not save? Issues. These are the issues we're talking about. New change just now updated, create a pull request, blah 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 and blah. So the idea was to, I think I didn't make a change. Okay, not on the master, sorry. So the idea is it triggers a build on only the master for this. So let's make the change on the master branch. So we'll probably just do nothing and just commit back. Then, so now I'm making a change on the master branch and also to the README file. So if you go to the pipeline now, it triggers a build for both pipeline. So this triggers only when there's a change to master. Now modern app triggers only when there's a change to the README file. So now let's see which one is running. So now this modern app is running. So the traditional method of doing this is to pass your application through a build pipeline. You probably need to install the dependencies that it requires to build the application on your agent, so to build your application. So for that traditional application to work, we had an agent behind the scene that had .NET Core installed. So when you run the .NET command, it worked fine. That was installed on the machine itself. Now the idea with containerization is we're not depending on the infrastructure. What we're doing is that we're pulling a Docker image and we're building our project inside that image. So whether you build it on a Linux environment or Mac OS or wherever, it still builds that .NET Core image fine. Now let me quickly go back why this stuff and show you how this works. So you know previously I told us how this containerization works. You have a Docker file, you get an image from it, then you run that image in the container. So in order for us to be able to build this project, we have to have a container, a Docker file, sorry. So what does this do? So from the very first line you see here, it says from mcr.microsoft.com/.net.core blah 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 and blah. Now this is the official .NET Core image. The way we pulled WordPress, official WordPress image, there's an official image for each development stack, whether you're using PHP, whether you're using Node and the rest. So the idea now is to pull that image, copy your code into that image, then do the whole build and stuff. So basically what's happening here is it pulls the official .NET Core image. Now it creates a new directory, expose 80 and 43. Now see where the magic happens. The magic happens from here. Now this application, this Docker file is sitting at the root of this application. So what it's saying is that, first of all, copy the Docker CS push file into the container. We don't need to understand this yet, but it's just like to just give a quick rundown because of time. So we say copy this file. So there's a file here that contains, we know the way for the .NET developers, the way it builds with the CS project file. So it's saying copy this file into the Docker image. And what's run.net restore. So it first of all restores the dependency. Then before it goes ahead to copy the whole content into the container. So what this means is copy the current working directory, that's this whole project, into the container image. So now what we have now is we have a container that have our code, a .NET container that we've copied this our code into. So the idea now of the Docker file is to specify the build, to generate an image. Now that image is immutable, it doesn't change. So if you check, we'll probably look at how all this stuff works maybe as time goes on later in the future. Let's go to the pipeline and we'll see the build was successful. So let me quickly open this up. What actually happened there? So the idea now is we build a container and we distribute it. So we get that container image to probably the operations team or wherever. So the idea now is if you build this image, now you are building it on the agents this Azure DevOps is running on. Now how do you get that image to the operations team to deploy? You know, initially I said this container is changing the way we do things. So instead of pushing your code now, you are pushing your whole application. Now the idea now is to push that code. Ideally, if you are an open source developer, you want to probably build your new stuff and push it to Docker Hub to make it available for everybody. Now you're in an organization. You can't push your code to Docker Hub. What is allowed, you can have your repository there. But your organization needs to find a way to maintain security around the images that have been produced. So the idea now is to push that, your application, into your organization's registry. So the way we have Docker Hub now, your organization now can set up their own registry. So the idea now, that is where all this cloud provider comes into play. So Docker itself provides you a way to run your own registry locally. So why would you want to do that when you can have the feature online? So the idea, what we did in this pipeline was to build that image and push it to the company official repository. Now if you go to the, now I'm just trying to log in. So I created a container registry account on Microsoft Azure. So what happens in this pipeline is the code was successfully built and the image that was generated was pushed to Azure Container Registry. Just a minute. So now what we have now is that application, that container image that was built and pushed to Azure. Now we deployed a file to Kubernetes cluster. Now what Kubernetes cluster does is once it gets that file, it reads the configuration and tries to put your cluster to conform to what is on that configuration file. So what it says is, in the file, I thought I opened it, sorry, let me not go back. So saying that create 2 instances of my application.
Sorry. So I don't get this cluster. Where is it on Azure?
No. Yeah, this I set up the cluster on Azure. Now you can set up a Kubernetes cluster locally, the way you can run Docker locally and everything. This one is on Azure, yeah. So the idea is how you access the cluster is through like a reverse proxy. So the way I'm trying to, now if you can see I'm browsing it on localhost. So to access that your Kubernetes cluster, you need to start a service, so for security purpose. So it's only the admin that have a login that will just set it up to be able to access. So you or whoever can't access the Kubernetes cluster outside. So the idea now was we got our deployment and we deployed it into a Kubernetes cluster. Now this is our deployment here, demo app, blah, 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 and blah. Age, 11 minutes. The image that is running, the name is demo app latest. Now, the power that comes with Kubernetes cluster. I can come here and say, my image is now it gives you visibility of out of the box of your infrastructure. Now we can see the CPU utilization and memory usage. I can come here and say, probably I've not configured my infrastructure properly. I can just come here and say I want to scale this my deployment.
When you change the scale, when you change the scale in the if you change it to 10, for instance, 10 instances, in my configuration file, I'm pushing to, if it's say 2, for instance, what will happen when it gets there?
So the next configuration that is deployed is 2. So the idea now is why you can do this here is quick fix to an error. You can just, okay, you don't want to go through that deployment cycle, CI, CD stuff. You just come here and spin it. Then later you go back to your configuration file and update it to 10. So the next time it's deploying that, you deploy it to 10. Ideally, you don't want to manually alter the scale. You use the horizontal scale to scale based on probably memory or speed.
That's a question. First question, can you use this cluster to manage your scaling of your infrastructures?
So that's where the power of cloud comes in. So if you want to say you want to scale your infrastructure, so you are running your Kubernetes cluster locally, let me say in your data center. Now you already have a fixed amount. There's a limitation to that. Your organization probably have just 10 servers. Now if the workload of your Kubernetes cluster grows, there's a point it goes, now there are different levels to this scaling. So there's a point to scale when you need to deploy more pods. When the workload reduces, that machine can be deleted. So it's not just even about scaling the pods in the cluster. Exactly, to gain the full, but due to restrictions and policy and stuff, especially in the fintech, they don't allow most of the services to be run on cloud. So you can go ahead to deploy your Kubernetes cluster in-house. So now you have the headache of managing the uptime and stuff. So the challenge will still come. Now you are managing your Kubernetes cluster yourself. There's a possibility that the data center, today we have some data center that probably go offline. Yeah. Then now that availability you are trying to achieve, you are no longer able to achieve that. So the idea to fully optimize this is to just run your Kubernetes cluster on the cloud. But it's fine to run
just an addition to what I was asking. Can you also manage scaling of the databases, interaction between your application, scaling your application and scaling your database?
So database is on a whole different level. So database now is a stateful application. Database, if you say you want to scale your database today, let me say you have 2 containers running in your Kubernetes. You have MySQL, and you decide to spin up 2 instances of MySQL. So what that means is that you have 2 different DB that data are being written to. I don't know if you get me. Now, the data that is in this one is not in this one. So ideally, scaling of database is, there's a limitation to that, running database on the platform, but there's a workaround to that. So the workaround is how you manage your storages in containers. So if you want to spin a container up now, the idea is if a container dies, the whole data dies with it. So before you spin that container up, you attach a storage to it. Ideally, you want to attach a network file storage to that container location. Now, the location where MySQL saves data, probably in the whatever directory it saves it, you mount that file share to that directory. Now, the idea is when you spin up 2 instances, those 2 instances are probably pointing to the same. Now, but databases are very sensitive. So the idea and the Kubernetes is still going. So the ideal way is to run your database on your service provider platform. So today on Azure, they scale your SQL database like no one. You can't even scale that. Yes.
I'm just to understand.
Okay.
It's not the network locally on my device.
Okay.
Speaking of 5G of my hard space. Now, using a container that's got a network for containers, and I store it on my Docker image, on my Docker runtime. Will it take the same 5G space on the Docker image, or will it take lower space?
So the image you are pulling has a fixed size. That's what I'm saying, it's immutable. Once an image is produced, you can't change that image. So if you start running a container and changes is being made, that's why when you shut down that container, probably remove it. If you start it again, it runs from where you got that image from. You get? So if you are pulling an image from Docker desktop, probably a .NET, a Windows container, there are two types, Linux and Windows. Probably you want to build a .NET, the ASP.NET, probably a web forms application. You can't use the regular Linux container. You get a Windows container, container image. Those are actually very large. If the image is 1.2 gig, if you put the image on Windows, it will be 1.2 gig. If you put it on Mac, it will be 1.2 gig. So now, when you want to now build your application with that project, that's where you start making changes. So you pull the Windows image. Now you add your source code. You probably add the SDK to build that whatever. You probably add whatever binaries you have to your application. When you build, so the application, the image starts going. You get? So the image starts going. So the idea now is like, this is taking. So let's say the idea now is to get the Docker image as lightweight as possible. So let me say you want to build a .NET Core application. Microsoft .NET Core, they are actually larger. Compared to you want to run a PHP app, the SDK is large. So the idea is you need to pull that SDK, copy your code, then use the tools to build that project. Now the idea with containers is that make this as lightweight as possible. Assuming there was time, or probably another session, you will notice that we started with a base image here, and this base image contains just the .NET Core ASP.NET 3.1 core. Then along the line, we got another image. Now we're having two form statements, an SDK. So the idea now is from a single Docker file, you can pull two images, get the functionality of one, which has the tools, the SDK, which are pretty larger than just the runtime. Build your code with that, then copy the output to the lighter image, which is the runtime. So if we can quickly step through this, you can see we first pulled Docker, the .NET Core runtime. We kept it aside, we just created the work directory /app, we exposed some ports. Then we went ahead to get another SDK in that same file. So what we did now is to copy our source code into this SDK. Now when we finished, we did a .NET Run build. Now if you see, we came here and did a from build as published. This is this guy. Run .NET publish, blah, 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 and blah. Then the final command was from base, this guy, right? In this directory, copy this output from publish. That's what you built in the SDK. Copy that into the first image you built. So the idea now is to, this is what we call multi-stage build. Get the whole SDK feature. So if you decide to build, now you can decide to build your container and run it in that SDK.
You said like once your container crashes.
So what? Okay, come. You said? Like today, if you are running your application now, probably all these Node.js apps that we're doing today, you are running your npm run. Josiah will know better. We are running our npm run, whatever. The idea is, once you make a request that throws an error, if you don't handle it properly, that's the end. That application crashes, right? So the thing is, so the application crashes. Now, you want to start a new instance of the application. Once you are starting this, the idea with Docker is that you are running an image. That image is immutable, nothing has changed. When you build your code and push that image, anytime I run it, is exactly what you push is there. So if I decide to spin up a container again, it's just going to use that image. All those stuff that's whatever has happened is gone. But there are different troubleshooting you can do. You can actually go back and try to start a failed container, which is actually valid, right? So if a container stops, you can go there and restart it. So that one still has the files and everything.
Developers code container crash.
Which is the operations code? It's developers code.
Multiple requests, workload. What the container cannot handle.
And that's where the high availability comes in. Once the workload is becoming high, it spins up another instance, and we are good. So I think that's that. We're supposed to. I think I still have some slide, or I think I'm done. I don't So I think we're MC.